Hi everybody, it's Mr. Pope from Wimbledon Grammar School for Boys, and today we're going to be looking at the 2019 Senior Kangaroo. And essentially this is a follow-on maths competition from the Senior Individual Maths Challenge from the UKMT, the United Kingdom Mathematics Trust. And, well, it's multiple choice. It's 1 hour long. You're not allowed calculators, any kind of measuring instruments, or squared paper. You're only allowed a blank or lined paper. This is to stop you trying to solve questions using grids and so on, and a pencil. Now the difference is with the senior individual challenge. There's 25 questions and then multiple choice from A to E. For the Senior Kangaroo, I believe there's 20 questions, there's less, but the multiple choice is in the form of a 3-digit number, i.e. from 000 up to 999. Yeah, here it is. And you have a separate answer sheet to write down the 3-digit number from 000 up to 999. Just have to be really careful. I've had students who have just circled the answer on the question sheet and left the answer sheet blank and received 0 for it, even though they've been told many times. I do little mistakes all the time. It's just rushing through, not reading the question properly. It tries to make you feel better by saying do not expect to finish the whole paper in the time allowed. And we'll talk about what's a good score for this kind of thing. So bearing in mind, to qualify for this competition, you needed to get a gold certificate, which was, what was it this year? I think it was a score of 90 out of 135. In the individual challenge, it was around about that. I'm not sure, don't quote me. The point is you can Google it. And for this one, if you score a question right, then that's 5 marks, and there's no penalty for incorrect answers. I think they just figure that it's not really a system you can game. When I mean you can game it, well, guessing a letter from A to E, I mean at least you've got a 20% chance of getting it right. Whereas guessing a 3-digit number, well, that's a 0.1% or 0.1% chance of getting it right. So really, it's not really a kind of test that you can game particularly. So what's a good overall score for this? Well, apparently you can either get a merit and that's it, and the merit grade boundary for this year was a score of 45 or more. So how many 5s in 45? So you're looking at 9 out of 20 questions. This is all inquiries. Okay, and then that's the page next. So I think it's a good paper. A word of warning: because this is the senior Kangaroo stuff, the problems are going to be a lot harder than intermediate. And if I use methods that are a little bit beyond what you may have learnt in Year 12 mathematics or all of these questions you should be able to solve really with GCSE knowledge. I mean, if you're a good GCSE mathematician, simultaneous equations, identifying quadratics and disguise, those are like the main tools. But if I have to solve a problem using calculus or using some vectors, or maybe even some mechanics, decision maths maybe, or some combinatorics, that kind of stuff, I'll just attempt them as I go through and I'll try and explain what I'm doing. I mean, I doubt very much you'll be using any mathematics in what I'll be covering over these coming weeks. But if I do, just bear with me. I'll say what it is, and if that technique comes up, then you can always Google it or just wait patiently or just look at the timetable I've put up on Google Classroom and you can see when I'll be talking about that next. Okay, so it's 60 minutes long, so let me just set a timer. Right, 1 hour. So 3, 2, 1, go. Okay, so what is the sum of all factors of 144? I don't think there's a quick way of doing this, so I'll just have to list them out. 1, 114, 2, 72, 3, and I want to say 48. 4 and half of 72, which is 36. 5 doesn't go. 6 and half of 48 is 24. 7 doesn't go. 8 and half of 36 is 18. Does 9 go? Yes, 9 and 16. 10 doesn't go, and then it's 12 and 12. Well, we've already done 12, so you can pipe that one off. Right, okay, we've got a 1, 2, 3, 4, 6 going on there. 1, 2, 3, 4 is 10 plus 6 is 16. So that's gone. If I look at these and this one, they're all multiples of 12, where I've got 1 12, 2 12s, 3 12s, 4 12s, 6 12s, and 12 12s. Okay, so I've got 1, 2, 3, 4, 6 again, which is 16. Plus another 12 is 28. So I've actually got 28 times 12 there. So 28 12s, 2 8s is 16. 2 times 4 plus 1 times 8 is 8. 6, 5 and 8 is 13. That's 336. 18 plus 16 is 34. Plus the 16 is 50, isn't it? So 336 plus the 50 is 386, and then I've got the 8 and 9 left over, which is 17. 386 plus 17, 6 plus 7 is a 3, remainder 1. 8 plus 1 is 9, plus 1. So my answer is going to be 403 for question 1. Okay, so it was moderately tidy. So looking back, I don't think there's a particular strategy for that. You just have to do it. Okay, I noticed that 2 to the 4 equals 4 squared. I tried to find other pairs of numbers with this property. Trying 2 and 16, I realised that 2 to the 16 is larger than 16 to the 2. How many times larger? Okay, that's just an indices thing. 2 to the 16. Well, 16 squared is 2 to the 4 squared, which is 2 to the 8. So 2 to the 8, what have I got to times that by to get 2 to the 16? When you multiply things, you've got to add the powers, so it's 2 to the 8. And 2 to the 8 is a power of 2, you should know, which is 256. So the answer there is 256. Okay, the diagonals of quadrilateral perpendicular. Okay. And the lengths of the diagonals are 14 and 30. So if I've got 14, let's say there, and 30 looking like that, this is clearly a kite. What is the area of that quadrilateral? Well, it's clearly half of this big quadrilateral. So I just do a half of 30 times 14, which is 15 times 14. And I know 15 squared minus a 15 is 15 14. So that's 225 minus 15. So I make that 210. Seems pretty straightforward. Okay, the integer n satisfies the inequality n plus 1 plus n plus 2 plus so on up to n plus 20 is 2019, or is greater than that. What is the minimum possible value of n? Okay, so I have got n 21 times, and I've got 1 plus 2 up to 20. Well, the sum of integers when r goes from 1 up to, say, not n, let's say a amounts, it's going to be a times by a plus 1 over 2. So if I'm going up to 20, that means the sum of those numbers is going to be 20 times 20 plus 1 all over 2. 20 over 2 makes a 10, so that's going to be 210. So now I have the inequality 21n plus 210 is greater than 2019. If I minus 210 from both sides, I believe that's 1,809. It's greater than 21. Okay. 1809 can be divided by 3 because 1 plus 8 plus... Okay, so 809 divided by 3. That's a 6. Remains nothing. 0. 603. So 21 divided by 3 is 7. So 603. And then what's 603 into 7? 7's into 7 into 60 goes 8, remainder 4. 7's into 43 goes 6, remainder stuff. So n has to be greater than 86 point something. So the smallest value of n is going to be 87 here. So I'd input in my answer sheet 087 for a 3-digit number. Yeah, that's pretty straightforward, just inequalities. Okay, let's tidy this up maybe. I think I'll change colour pen as well, because this black stuff's not really separate. Okay. Oops, daisy. Okay. Identical regular pentagons are arranged in a ring. The partially completed ring is shown in the diagram. Each of the regular pentagons has a perimeter of 65. A regular polygon formed as the inner boundary of the ring and has a perimeter of P. What is the value of P? Right, so what it's asking for is if I trace the perimeter inside the shape like that, then that's P. So clearly P is some multiple of 13, because 65 divided by 5 is 13, because it's 50 plus 15, so 10 and 3. Ideally, I want to know the angle, the exterior angle of this polygon, because once I know what that is, I can then check to see how many 360s go into it. I know that angles in a regular pentagon must be 108, because angles in a pentagon is 540, just from common knowledge, and divide that by 5 is 108. That means this angle here, because it's a straight line, must be 72. So this angle here must be 108 minus 72. 8 minus 2 is 6. 10 minus is 36. So if that's 36, then there's going to be 10 of these. This is a 10-sided shape. So 10 times 13, so the answer is 130. So P is 130. Yeah, that's pretty easy. Okay, 6. For what natural numbers A and B are we given that 2019 a squared minus b squared, and when a is less than 1,000? Okay, so knowing the prime factorizations would be helpful here, because a squared minus b squared is a minus b times by a plus b. I mean, that's an obvious difference of squares, so we've got to factorize 2019. Well, 2019, 2 plus 0 plus 1 plus 9 is clearly 12. So this is a multiple of 3, and 2,119 divided by 3, 6, remainder 2, 7, 3. So it's 3 times 673. Is 673 prime? Well, the check is we square root that. So the square root of 673 is stuff. I know 625 square rooted is 25, and 26 squared, 6 6 is 36, 6 2 is 12, plus the 3 is 15, 2 times 6 is 12, 2 times 2 is 4, plus the 1 is 5. So this is 676. So that means 673 is 25 point something. So we need to check all the prime numbers up to 25, which is 2, 3, 5, 7, 11, 13, 17, 19, and 23. It's clearly not in the 2 times table. 6 plus 7 plus 3 is 16, so it's not in the 3, it's not in the 5. 7, we double the last digit and we take it away. So 3 doubled is 6, 67 minus 6 is 61, it's not in the 7 times table. 11, we do the alternating sum, so plus 6 minus 7 plus 3 is 9, minus 7 is 2, so it's not in there. 13, we're going to have to times by 4 and add on the last digit. So 3 times 4 is 12. 12 plus 67 is 79. And that's not in the 13 times table, so that can go. 17, we times by 2 and add. No, we don't times by 2. We times by 5 and we subtract, that's it. Because 7 times 5 is 35, 1 minus 35, yeah, okay. So 673, 3 times 5 is 15, we take that away, 7 minus 5 is 2, 6 minus 1 is 52. 52 is not in the 17 times tables, because 3 17s are 51, so that can't count away. 19, we double the last digit and add it on. So it's very similar to 7 times table. So 673, double 3 is 6, add it on is going to be 73. Well, 4 19s are 76, aren't they? So that's not going to work. 23. What would be the rule for 23? Would you times by 7 and add on? Yep, 3 times 7 is 21, add 2. Okay, fine. So 673, take the 3, times by 7 is 21, add it on, 7 plus 8, 80, lol, 23 is not a multiple of 88, or rather 88 is not a multiple of 23. So actually 673 is prime. So I wasted a bit of time there. I mean, you could argue that if you'd done your prep, you'd know what the prime factorizations of this is. I was just checking. Okay, so long story short, I've wasted a lot of time. So really, a minus b times a plus b is either going to be 1 times 2019, or it's going to be 3 times 673. Is that right? Yes. Okay, so if I add these two things together, then a minus b add a plus b is going to be 2a, and that's if you was to add these two factors, that's 2020, so an a would be 1010, and a has to be less than 1000, so it can't be that, so it must be the 3 times 673. So 2a is when you add them together, so 3 add 673 is 676, and if I halve that, that's a 3 remainder 1, that's an 8. So the value of a I got was 338. Okay, smooth sailing so far. 7. How many positive integers such that both n plus 1 over 3 and 3n plus 1 are 3-digit integers? Okay, so a 3-digit integer, what does that mean? Well, that means n plus 1 over 3 must be greater than or equal to 100, but less than 1000. So if I times by 3, that becomes 3000, that becomes 300. And if I minus 1, then that's 299. And this becomes 2999. So we've got an equality based on this thing. If I do a similar thing for 3n plus 1, then 3n plus 1 has to be less than 1000, but greater than or equal to 100. If I minus 1 from both sides, that's 999, that's 99. Divide by 3, that's 333. And that's greater than or equal to 33. So really, the only overlap we've got here is n is greater than or equal to 299, but it's less than 333. So that's going to give that n has to be greater than or equal to 299 and less than 333. Also, they give integers. So n plus 1 must be divisible by 3, right? Because if I'm dividing by 3 for this thing, then n plus 1 must be a divisible thing by 3. So I want to know what are all the things divisible by 3 if I add 1 to both sides of 300 and 334. Well, it's all the numbers 300, 303, and so on up to 333. So be careful. What have I got how many times am I going up? Well, 300 to 333 is 11 lots. So I've got 1 plus 11 jumps, so there's 12 steps. So the answer here is just 12, 0, 1, 2. Okay, so that was all right. That wasn't too bad. Okay, the function j of x is defined as that. How many distinct real solutions of the equation j of x is 0? Right, let's solve the first bit. Let's call all of this inside g. So j of g, when does that equal 0? Well, it equals 0 here and here. So that means g equals either -4 or 0. Next up, let's call this thing, well, that's just j. So when does g of j equal to either -4 or g of j, lol, why did I choose g? That's a tongue twister. Or that equals 0. Well, for the bottom one, that's easy. I've solved that already, so it's -4 and 0. For when it's -4, it's going to be back here. So we have to solve when 4 plus x equals -4, which means x is just going to equal -8. So now we have 3 solutions. And now, so I've done this bit, now I just want j of x. And now I want the solutions when j of x equals either -8 or -4 or 0. But when it equals 0, I'm going to get 0 minus 4 again. When it's -4, I'm going to get -8. And when it's -8, then I want to solve 4 plus x equals -8. So x is -12. So that's going to be -12. So how many distinct solutions of the equation does it have? Well, it's got 0, -4, -8, and -12. So there are 0, 0, 4 solutions. 4 solutions. Okay. Right. This is a mess. Let's whack that in here. Okay, what is the smallest 3-digit number k that can be written as that? Okay, well, let's say a has to be smaller than b for no particular reason. I mean, it's symmetrical, right? A to the b, doesn't matter which way round they are, it's the same thing. So if a was 1, then the largest this could be is 1 to the 9 plus 9 to the 1. So lol, that's just going to be 10, so that's dumb. So a is going to have to be at least 2. What's the most it could be? 3-digit number. What's the smallest 3-digit? Well, 2 to the 7 is 128. So let's try 2 to the 6, which is the next smallest one down, which is 64. Yes, so then 6 squared is 36. 64 plus 36, 100. Lol, you're not going to get any smaller 1-digit positive integer than 100, so we'll just stick it as that, 100. So 9 is just 100. Okay, what is the value of this? Okay, let's partition this off, do this bit first. This is clearly going to be the square root of this times this, which is going to be 13 squared minus the square of what's inside. So that's going to be 28 plus root 281. 13 squared is 169. If I minus the 28, 9 minus 8 is 1, 6 minus 2 is 4. 141. So this whole thing becomes the square root of 141 minus root 28, 281. So when I multiply that by the root of 141 plus root 281, which is the second bit, oh, you're going to get difference of squares again. So this is going to be the square root of 141 squared minus the square of the square root of 281, which is 281. Okay. Geez. Okay. Right. So 281. Oh, do I want to do 141 squared? No. Well. Okay. Okay. If you let a equals 141. Then this whole thing here is the same as a squared minus 2 lots of a, and then I have to add 1, don't I? Yeah, because 2 lots of 141 is 282, which is nice, that's why I picked it. And then a squared minus 2a plus 1, that factorises to a minus 1, all squared. So if I square root that, then you're going to get just a minus 1. If a is 141, the answer is going to be 140. So that's my answer for 10, 140. Okay, 11. In the triangle ABC, lie on the side AB, such that A to N. Okay, so we've got some isosceles triangles going on. BM to BC is the same. We know that MCN, yeah, it's 43. Find out the side. Okay, fine. So if we call this one, let's call it alpha, and let's call this one beta, then this angle must be 43 plus alpha, and this angle must be 43 plus beta, because I know that this angle is the same as this one, because this is an isosceles, those are the two sides the same. And this angle must be the same as this one, because you've got two sides the same for that isosceles triangle. Okay, this shouldn't seem so bad, because so if we consider this middle triangle here, then 3 lots of 43 is 129. So 129 plus alpha plus beta equals 180. If we minus 129 from both sides, then that means alpha plus beta is 51. And we wanted to work out what this angle up here is, which is just 43 plus that alpha plus beta, which we know is 51. So the answer is 94, so the answer is 094. Okay, that wasn't too bad. Right, what is the value of a squared plus b cubed plus c? Okay, right, surds. Right, let's make them indices. So this is all to the power of a third. And then 16 and 2 are both powers of 2. So 16 is 2 to the 4, and I'm timesing that by 2 rooted, which is 2 to the half. So this is going to be, when I multiply stuff, I add the powers. So 4 plus a half is 4 and a half, which is 9 halves. So 2 to the 9 halves, and the third of 9 halves is 3 halves. Bracket rule means you multiply the powers. What have we got over here? This is all to the power half. And then I'm just going to, well, 9 is 3 squared, so 9 is 3 squared, and then the cube root of 9 is 3 squared, and then cube rooted, so over 3. Add powers together, so 2 plus 2 thirds, well, that's 6 thirds, plus 2 thirds is 8 thirds, half of 8 thirds is 4 thirds. Last one, I've got 2 to the 5th, and then doubled, so that's just going to be 2 to the 4/5. And now if I want a squared, then I square this thing, so it's 2 cubed. If I to the 3 this thing, that's 3 to the 4, and if I to the 5 this thing, that's 2 to the 4. 2 cubed is 8, 2 to the 4 is 16, 3 to the 4 is 9 squared, which is 81. This is 89. If I add 16, that's 95, that's 105. Coolsies. Right. 13. The real numbers a and b, where a is bigger than b, are the solutions to that. Oh, what is 20a squared plus 18b squared? Okay, fine. This is a quadratic in disguise. Because if I let y equals 3 to the x, then y squared equals 3 to the x squared, which is 3 to the 2x. 3 to the x plus 1 is the same as 3 to the x times by 3 to the 1, which is 3. So this thing is actually 30 lots of 3 to the x, that's 30y. 3 to the 2x is y squared, and this becomes plus 81. Oh, this probably does factorize. I'm being a silly boy, but I'm going to complete the square. So half of 30 is 15. Minus 15 squared is 225 plus 81. What have I got to add? It's 104. It's 225 minus 81. That's 4. Can't do that. 12, 4. 144. So that means y minus 15 squared. If I take all that to the other side, it's 144. So then y equals, add the 15 plus or minus the square root of 144, which is 12. So y is either going to equal 15 plus 12, which is 27, or y equals 15 minus 12, which is 3. And since y is 3 to the x, then that means x is 3 to the what power is 27, well that's 3, or x to the what power is 3, that's 1. So it looks like where a is the bigger one, this is a and this is b. So I've got 20 lots of 3 squared plus 18 lots of 1 squared. So that's 18. 3 squared is 9, 9 20 is 180, so the answer is 180 plus 18, so I make that 198. Bosh. Okay, a number n is the product of 3 distinct primes. Okay, so n is a times b times c. How many distinct factors does n to the 5 have? Okay, so n could be a to the 5 times b to the 5 times c to the 5. And, okay, I just want distinct factors. So I could pick anything from a to the 0, a to the 1, a to the 2, and then I could pick b to the 0, b to the 1, up to b to the 5, or c to the 0, So I've got 6 choices for each. So if you see this as like a combination lock that can only have numbers from 0 to 5, then I've got 6 by 6 by 6 combinations. I want to say that's 216. Let me just check. 36 times 6. 6 is a 36. 6 3 is 18 plus the 3. Yes, okay, 216. Yeah. Okay, that wasn't too bad. Right, 5 bunchkins sit in a horizontal field. No 3 bunchkins are sitting in a straight line. Okay. Each bunchkin knows the 4 distances between her and each of the others. Each bunchkin calculates and then announces the total of these distances. These totals are... Okay, so what's going on is, say, for example, you've got something like this going on. So if they're not in a straight line, what does that mean? A straight line painted joining each pair of bunchkins. So if they were in a straight line, then the line from here to that end bunchkin would cover, you wouldn't need to paint this bit. Okay, I get it. So, right, so that means when they call out their distances, if you say A, B, C, D, E, then A will call out this distance. No, they've all got to be connected, haven't they? See, we did this in decision maths. This is a complete graph. Bosh. Yeah. So, okay, 1, 2, 3, 4, 5. A, B, C, D, E. And then you've got all the connections like that, because they've worked out their distances between them. And they don't lie on straight lines, so I could rearrange it to look like that. And now from A's perspective, she's going to call out AB, and then AC, then AD, then AE. And then from D's perspective, from then we go to B, he's going to call that one out a second time, then BC, then BD. BA, BC, BD, yeah. And then, they're all going to get called out twice, aren't they? Because you're just going to, because A is going to call out A to B, and then B is going to call out B to A, which is the same as A to... okay. So, a straight line. So all I have to do is add all these together and divide by 2. So 17, 43, 56, 66, 76. 7, 3 is 10. 3, 6 is 18, so this is 28. 4 and 6 is 10. 15 with the 5, 16. Plus the 2 is 18. Plus the 7 is 25. 258. Okay, and then 258, divide that by 2. 2's into 2 go 1. 2's into 5 go 2, with 1 left over. 2's into 8 go 9. So 129. Doesn't actually say what these distances are, they? No, 129 whatevers. Okay, question 16. The real numbers x and y satisfy the equations blah blah. Okay, let 2 solutions be that. Simultaneous equations. Right, okay. Well, I spot a minus x there and a plus y. If I call this equation 1 and this equation 2 for no reason, let's call the other, it doesn't matter. Honestly, it doesn't matter. I'll call this 1, I'll call this 2. If I do equation 2 minus equation 1, the xy's cancel, and y minus x becomes x plus y, then 208 minus 180 is 28. Cool. That's fine. And then let's have y equals 28 minus x. So now I can bang that into maybe this one over here. So x times 28 minus x minus the x equals 180. So I'm going to have 28x minus the x there, so that's actually 27. X times 28 is 28x, minus the x is going to be 27x. X times minus x is minus x squared, and then minus 180 equals to 0. If I times the whole thing by minus 1 and rearrange, and x squared minus 27x plus 180 equals to 0. Oh man, my factorization is pretty bad. Have we done this before? I want to say 12 and 15. 5 times 2 is 10. 5 times 60. So that's 120. Yeah, okay. So it's actually x minus 12 times x minus 15. So it looks like x can be 12 and 15. And since, where is it, x plus y equals 28, then what have I got to add to 12 to get 28? That's 16. What have I got to add to 15 to get 28? That's 13. And the value of, you've got x1 plus x2, so 12 add 15 is 27. Add, and then 10y1 plus 10y2, which is going to be 10 lots of 16 plus 13 is 29. So I've got 290 plus 20 is 310. Plus a 7, so the answer is 317. How are we doing for time? Oh, 28 minutes. Loads of time left. Good. He says this, and I bet the last couple of questions are absolutely rock hard. Okay, in a triangle AB, where the angle BAC is 120, the length of AB is 1, 2, 3. Point M is the midpoint of the side BC. Oh god. Right, okay. Triangle ABC, where BAC is 120. The point M is the midpoint of side BC, and the line segments AB to AM perfect. Okay, fine, let's draw this. So 120 degrees. I don't know, that's going to look fairly like that, yes? Okay, where this is A, we'll call this B, and we'll call this C. The length AB, okay, that's 1, 2, 3. The point M is the midpoint, let's say it's over there. And the line segments AB to AM are perpendicular. Okay, so I whack that like that, so that's 90. Okay, what is the side length of AC? Okay, so how about I... well, that's 30. You know what, if I extend this, so and that comes down like that, so that's 90 as well, then because I've split this side in half, then this must be the same as this, so that is actually 123 as well. If that's 90, 30, this must be 60. And I want to find this x. Oh, I've got the adjacent hypotenuse. Yeah, boy. So cosine 60 is the adjacent, which is 1, 2, 3, over the hypotenuse, which is x. Cosine 60, cosine 60, cosine 60. I want to say that's a half. How do I know that? Well, because if I have a 2 by 1, I drop that down, so that's a 1, so that's 90, so that's 60, and this is root 3. Then adjacent over hypotenuse, yeah, that's a half. 1, 2, 3 over x, or lol. If I times by x and times by 2, then x is 246. That's what we wanted. AC was 246. Bang. That wasn't too bad. Right, an integer is said to be chunky if it consists of non-zero digits by which it's divisible when written in base 10. For example, the number 936 is chunky since it's divisible by 9, 3, and 6. Okay, how many chunky integers are there between 13? Okay. Okay, let's go for the easy ones. It's non-zero, right? So the easy ones will be like 22, 33, 44, 55, 66, 77, 88, 99. All the multiples of 11. 101, no, because it's got a 0. And 111 will work. Right. Are there any other ones in between? Okay, right, fine. So C is my chunky number, and that's 10 lots of x plus y, where it's xy is the number. So y must be chunky number minus 10x, and since chunky number is divisible by x and 10x is divisible by x, then y must be divisible. Okay, so this will only work if the integers, the number, the units is divisible by the tens. That's not really a good enough check, is it? Let's speed things up though. Okay, so let's do the 13 up to 19. That's going to be hardest. 13, no, because it's not divisible by 3. Well, 13 up to 19, they're all divisible by 1, so that's dumb. 14 is not divisible by 4. 15 is divisible by 5. 16 is not by 6. 17 is not by 7. 18 by 8. 19 by 9, no. Okay, so now for the 20s, I've got 21. Well, I have to pick all the even numbers, don't I? Because the tens digit is a 2. So it's going to be 22, 24, 26, 28, not 30. 22 I've done. 24 is 1 because that's divisible by 2 and 4. 26, that's not divided by 6, and 28 is not either. Okay, 30s, I have to do all the multiples of 3. I've done 33, so 36 and 39. 9 is not divisible by 3, so that can bugger off. 36 is okay. 44, 48. 44 is, I've done that one. 48 is divisible by 8, so that's cool. 50s, well, I've only got 55 and so on. I've done that. 66, well, there's no, 77, 88, 99. There's nothing in the hundreds because that's 0 in the middle. 110 is not going to work. Will 112 work? Yeah, because it's divisible by 2, so 112 will work. Yeah, so we've actually considered. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I count 14 numbers, so my answer would be 0, 1, 4. 0, 1, 4. Okay, the square ABCD has side length 105. Okay, fine, so let's do that. Oh man. Okay, here's my square. Oh mate, come on. Here's my square 105. 105 and side lengths A, B, C, D. Okay, the point M is the midpoint BC. Okay, so there it is, M. N is the midpoint of BM. Okay, so N is there. And the lines BD, so that line like that. Okay, no. Mate, my pen's not behaving itself. B to D is like that, and A to M goes from there to there. This point is P, and the lines BD to AN, so a line looking like that. That's Q. What is the area of triangle APQ? So the area of this triangle. Right. I'm probably going to use a combination of vectors and coordinate geometry here, because if I take the cross product of A to Q and I cross it with A to P and I halve it, that will give me the triangle APQ. And we'll learn about this in vectors, but essentially you're going to see how this plays out. So if I define A to be my 0, 0 coordinate axis, and B is going to be 0, 105, then B to D, because that's a slope going downwards, so line B to D is just going to be y equals minus x, because it's got a slope of minus 1, plus 105, because it's been moved up. Line A to M, well, that's just a gradient of not 1, but it's 2, so that's y equals 2x. And line A to N is going to be y equals, that's going to be 4x, because it's 4 times as steep. So if I want to find the coordinates of P, then I solve simultaneously A to M, which is y equals 2x, and I set that y equals to BD, which is minus x plus 105. Add x to both sides, so that's 3x equals 105, divide by 3. 3's into 1 doesn't go, 3 into 10's go, 3 into 1, that's 35. So therefore y is double that, which is 70. So I've got the xy coordinates of P. And I can do a similar thing for Q by setting 4x equal to minus x plus 105. If I add x to both sides, that's 5x, that's 105. So x is 21 and y is 4 times that, which is 84. Right, now that I know those two things, this is what I'm going to do. So what I'm going to do is to take the cross product, I will write these out as column vectors. So 21, 84, and then 35, 70. I will put a 0 there, a 0 there, and then I, J, K, like that. And then essentially we're working in the I and J vector plane. So you'll learn about this with determinants and stuff, but the short answer is the answer is going to be K, which is irrelevant here, times by, well, it's just 1, because we just want the magnitude of this thing. So that's the magnitude of the determinant. So it's going to be 21 times 70 minus 35 times 84. And then, because I want the triangle, I want a half of that. Right, so distribute this out a little bit. So 70 is 35 times 2, so this is actually 42 times 35, minus 84 times 35. And if I want to halve this, I can take a factor of 2 out of everywhere, so it's actually 21 times 35 minus 42 times 35. And 21 minus 42 is negative 21, but I want the magnitude of this thing, so it's actually going to be 21 times 35. 5 times 1 is 5, 5 times 2 is 10, 3 times 1 is 3, 3 times 2 is 6, 5, 3. I make 735 units is the answer, 735. Okay, oh, on the last question already. Okay, each square in this cross number can be filled with a non-zero digit such that all of the conditions in the clues are fulfilled. Okay, fine, it's a cross number. The digits used are not necessarily distinct. Okay, so they can be anything. And they're non-zero, so we can deal with anything from 1 to 9. What is the answer to 3 across? Okay, 1a, a composite factor of 101. Okay, so 1001. It's not divisible by 3 or 2 or 5. What about 7? So we take the last digit, multiply it by 2, take it away. 100 minus 2 is 98. 98 is divisible by 7 because it's 28 plus 70. So that means 7 goes into 1001. Okay. 7 into 1001. Once begins to 10, remainder 3, says 4, remainder 2, 143. That's nice because it's 7 times 11 times 13. Okay, a composite factor of 1001. Composite just means that it's not a prime number, so we can multiply any combination of these. So I could have 7 times 11, which is 77, or 7 13s, which is 91. Well, the final combination is 11 times 13, which is 143. But this thing's a 2-digit number, so that won't work. So it's either going to be 77, so I'll do it like a Sudoku, 77 or 91. Those are my two options there. Okay, so 1 across is pretty much done. We won't look at that anymore. 1 down, 1 more than a prime, 1 less than a prime. Now, because the option 1 block either starts with a 7 or 9, let's list out the prime numbers. So 71 is prime, 73 is prime, 75 isn't, 77 isn't, 79, I'm pretty sure that's prime. And then the 90s, 91's not prime, 93's not prime, 95's... is 91 prime? No, lol, that's 21 plus 70, it's in the 7 times table. 93 isn't, because it's in the 3 times table, 95 isn't. I think 97's prime, and 99's prime. So actually, it can't be the 9. I think it has to be 72, 1 down, because that's 1 more and 1 less than a prime. So that means this is 72, and this must be 77. Okay, 3 is not a palindrome, so that means 4 can't be 2. Okay, 2 down, a multiple of 9. That's not particularly helpful at this stage. Okay, 5 across, pq cubed, where p and q are prime, and p doesn't equal q, and 4 p cubed q, but it's the same q as p and q is 5. Oh dear, this is not good. Okay, well let's start with some simple stuff then. Let's say p, oops daisy, let's say p is 2 and q is 3. Then what's p q cubed and what is p cubed q? And by the way, it looks like this is symmetric, but so by doing this, essentially we can swap them over. So q cubed, 3 cubed is 27, times by 2 is 54, and 2 cubed is 8, times by 3 is 24. So no matter which way you look at it, the last digit is always going to be 4, so potentially that could be a 4. And these two switch over depending if I swap p and q over. Now what if this was a 2 and 5? Will that change it much? I don't think this is going to work, is it? Because 2 to the 5, 2 times 5 cubed is 250, because 5 cubed is 125, times, okay. And then 8 times by 5 is 40. And although they have the last digit, this is a 3-digit one, so it's not going to work. And then clear, and vice versa, you can swap them over. And 3 and 5 is the next smallest combination. And oh man, that's going to be 7. Oh, geez. 3 lots of 125 is 375. And 27 times 5 is 135. They're both 3 digits, that's not going to work. So it looks like this definitely has to be a 4. And it looks like that this has to be the 50 and this has to be the 20. The reason why this can't be a 2 is because then it starts and finishes with a 2 and it can't be a palindrome. So it looks like that's guaranteed a 5 and that's a 4. Not a 4, you silly boy. That's a 2. Okay. And then 2 down, a multiple of 9. Well, 7 something 2 being a multiple of 9. To be divisible by 9, then the digit sum has to be divisible by 9. So that can, and since 7 and 2 is 9 already, that means it can either be 702 or 792. And I think it said a near non-zero digit, so we can't have 702, so it must be 792. So the answer must be 295. Okay, that's it. Yeah, moderately tricky paper. Got 11 minutes, 12 seconds left. I'd probably spend it checking my answers, but I'm feeling pretty good already. Not sure. I don't think I made any mistakes. I think I just went pretty carefully as I went. But yeah, so I think that's pretty much it. I could have spent a lot of time on, where was it? Not this one. This one, 19, the square thing. I think knowing vectors and a bit of coordinate geometry just sped that question up quite a lot. I probably could have dissected it into triangles and other things, but Well, there's probably going to be some similar triangles going on here. Yeah, I just don't. I just didn't want to get involved in that. I think I immediately spotted that the area of a triangle, especially when I don't have a perpendicular height, would have just been that. I could have used the cosine rule, I'm guessing, but yeah, just vectors would have sped things up quite a lot there. But it's up to you. Anyway, I hope you found that useful and have fun.